Good evening, everyone, and welcome to the panel discussion on battery materials, semiconductor, and the advanced chemicals. I think it's important, and before we begin, it is essential to highlight the importance of the topic first. Whenever I participate in any presentation on economy or industry with bankers or lenders, the first question that is asked is private capex in India happening? And our view is that yes, it is happening, but it is not broad-based. There are pockets of growth, and if you compare the last 5 years of capex vis-a-vis the next 5 years of capex, very essentially the previous panel spoke about some of them from a growth driver point of view. Conventionally, capex in India was driven by steel, oil and gas, commodities, cement, pharma, textile. From the next 5-year point of view, we are looking at 3 E's of growth. The first E is electric vehicle, the second E is electronics, and the third is energy transition. And obviously, we have a strong panel and experts here who will deep dive into some of these from the backward integration as well as specialty chemical point of view. So I think with that context, let me put my first question to Dr. Mayukh. Sir, I think from an opportunity point of view, how do you see expansion of India towards domestic manufacturing, 1, PLI 2, and 3, China plus 1 policy, supporting some of the industrial growth and how it's supporting the growth of chemical industry?
2 points I'll make before I start. Views are personal, don't reflect my company's policy. And secondly, I'm probably the odd man out. I may not be in sync with this panel because of my views. You are free to throw me out of here. I look at the EVs with some kind of fear. The metals that are used in EVs, recently when I saw data, we don't comprise among the top 3 in the world for its production. So where are they coming from? They are actually coming from countries which are probably politically volatile. Rajiv just mentioned no during our discussion in the lunch, that there are other countries which are coming up. So I'm glad to know that. The other aspect is also the tariff barriers. The rare earths which are coming mainly from China, the US tariffs have made a whale of a difference. China has restricted exports. So I don't know how we are going to overcome this. I read recently India's growth on the EVs is ranging between 30 and 40%. So the metals needed for electric vehicles is 6 times what we already have in a conventional. So my question is to myself, how are we going to do it? Sometime back I read India has a lot of resources for rare earths, so we need to work on it. I'm not sure how far we are doing that. Correct me if I'm wrong. Regarding the recycling of the metals, that's another industry. I'm confounded that it is being called a green whatever technology. The source of the metals is coming from mining. We know how mining works. We also know the extraction processes are very severe and toxic, and purification may be even more than that. But there again, I stand corrected if anybody has something to say. Regarding the PLIs, I think I'm not sure how the PLI of the other industries have worked in the past, but there will be need for PLI in this sector right up to the backward integration, because the production, if we have to do internally, will need a lot of resources and a lot of capital. I hope I've answered your question.
Yes, sir, definitely. I think it's an interesting view. Might be deviating from the industry view, but that's an interesting perspective. Rajiv, coming to you, I think if I look at government's vision, it's 30 at 30, which is achieving 30% of EV penetration by 2030. That's the vision with which we are moving ahead. Uh, while the regulatory aspect is one angle, cost competitiveness also becomes very, very critical to adapt EV from a consumer point of view. From battery chemistry or chemical point of view, what are the key drivers of cost and how do you look at them from a medium-term perspective?
Okay, so when we look at manufacturing of chemicals that go into an EV battery, typically a lithium-ion cell, one could look at 3 or 4 points. One is the raw materials that go into the manufacture. Second is the processing cost. And third is the purity that is required. So if I look at the raw materials, the major raw materials that go in a lithium-ion cell are minerals like nickel, cobalt, lithium, manganese to some extent, and graphite. So depending on the chemistry of the lithium-ion cell, so if it is a NMC, nickel, manganese, cobalt chemistry of a cell, these metals would cost up to 50 to 65% of a raw material cost. If it is a LFP chemistry cell, then there is no nickel and cobalt there, but the lithium and graphite would add up to about 50% cost. So the sourcing of these raw materials is definitely a major cost as far as lithium-ion is concerned. Lithium-ion batteries are concerned. Second thing is processing cost. In processing cost, if one goes to make the lithium salts that are required in lithium-ion cells, one needs to cool down the mother liquor which is used in the processing to down to -50, -55 degrees Celsius to get the crystals out in a pure form. So there's a high power cost involved in cooling down the reaction medium to such low levels. Even when somebody is making cathode active materials, whether it's a cathode or anode, one has to do sintering of minerals at high temperatures like 800 degrees for a batch that lasts for up to nearly 24 hours. So there's a very high energy cost involved while making cathode active materials or any electrode materials. So these raw materials and the energy usage comprise a very high element of cost. And third is the purity. The purity of battery chemicals is even more purer than pharma grade chemicals as far as metal content is concerned. Metal content in all the elements or components that go into a lithium-ion cell requires levels less than 1 ppm. Typical industrial products have 200 ppm, 300 ppm. Here one needs to get down to 1 ppm. So therefore the unit operations that are required are quite extensive. And finally, as far as Indian context is concerned, we are at a nascent stage. Our scale is not big. So the lack of scale adds to cost for Indian operations today. But then as Indian companies cater to electrification of mobility or energy storage, we'll need to look at catering not only to Indian market, but to global markets so that we can achieve scale and drive down costs for all the other points that I mentioned earlier.
Absolutely, Raju. I think you touched upon an important aspect, which is scale of operation. And that's where, Dr. Mayukh, you were referring to scale where India is probably competing with China. Kalpesh, my question is to you, bringing and connecting that point. As industry moves to expand the EV penetration, obviously the role of battery chemicals will be very strong by then. How do you see challenges that companies will face when we move from lab to industry transition, especially how we are adapting to the configuration size of two-wheeler, three-wheeler, and other configurations?
Sure, thanks. So Rajiv touched upon a few points, but you mentioned lab to industrialization, right? So typically, as it is with any chemical process, it's the same with battery materials manufacturing as well. You take a product, you make it in the lab, you have to go to an intermediate scale, which is the pilot, and then you go to the commercial scale. One thing that is a little different from a typical commodity chemical here is the fact that we are not only dealing with material purities, but we are looking at their physical properties and also the electrochemical performance. So that's where the customer comes in. Say for example, if you have a typical commodity chemical, you know you have to achieve a certain purity and you have to achieve certain purity of the impurities. You have that profile. You come up with a plant. If it produces spec material, you can actually go and sell it in the market. That's not true for battery materials. For battery materials, there's an intermediate step because the customer will actually give you validation on the electrochemical properties. So even before you can lock in the process, right, you need to have that very critical qualification process. So this is a very key differentiator between the typical chemical products versus the battery materials products. So that's one. The other thing Rajiv touched upon is the cost of production, right? So at the lab and the pilot scale, that and the qualification really determines your process, your commercial process. One of the things that again is kind of lacking in India because the battery industry is in a very nascent stage is we don't have machinery or equipment suppliers. You know, the equipments are still imported from China. We can develop that in-house, working with our Indian suppliers. We can localize that to a certain extent, but some of the equipment, very critical equipment, like the calcination, he mentioned sintering, that is still, you still have to import that. So that, again, is a challenge in trying to keep the costs low. And the third and the fourth points. Third point is obviously sustainability. When you're working at the lab level, you know, you can work with byproducts or effluents or waste streams, things like that. You can manage them very effectively. But the premise here is this is EV. It has to be cleaner. It's an alternative to the fossil fuels. So you have to be mindful of the fact that when you commercialize a product, you have to have as much, it has to be done sustainably, right? With low emissions, no waste products and things like that. The last thing, again, Rajiv touched upon is the raw material context. For graphite, it's synthetic graphite or natural graphite. One of the things that you can do is by innovation, you can actually supplant the existing raw material chains, like we've done, for example, with Epsilon, to come up with a supply chain that will be more local. As regards with cathode, you know, it's lithium for the LFP, also for NMC, but then the other ones are cobalt, nickel, which are sensitive, you know, we depend on imports. But the government of India is actually working on several initiatives with other governments in the world to establish a non-China or a secondary supply chain for these as well. And that will help to reduce costs as well. So I think these are some of the challenges that we are facing, but you know, going from lab to commercial, all these points have to be kept in mind.
Thanks, Kalpesh. I think that's interesting. It's a journey, may not be covered in short span, but I think it's going to be an evolving path. So far we spoke about EVs. Let me go to the other E, which is electronics, and the backward part, which is semiconductor as well. So I would like to come to Hemant and Ambuj. First, Hemant, to you. We are referring to two vision that government is looking at. One is semiconductor mission. Second is electronics PLI. And obviously we are seeing the second leg of it, which is backward integration of electronics, which is semiconductor electronic component manufacturing. Now, from semicon point of view, we also see some of the investments in Gujarat, Assam on OSAT and ATMP. How do you see, one, the growth of semiconductor industry in India, and two, because of that, the allied industries, including the specialty chemical?
Okay, thank you. So about the growth, the first point you asked about the growth. So, you know, a very good connect with next gen. What Mr. Praveen Prasad also mentioned, this is the next generation topic, right? And the semicon market, which is, we are all surrounded with the screens. Everywhere around, you get up in the morning and you have some screen, and you go on the road, there's a screen, in the office there is a screen, everywhere we are surrounded with the screen. That's the market what we are looking for. already we are second largest consumer of the semiconductors in the market. And it's growing, the highest population. And in the rural part also, you see the screen as a common topic today, right? So this is where the growth is looking at the entire market. What we see this as a definitely good future. Yeah? And the good part is already the investments are done by large players in this market already. As you mentioned in Gujarat, Assam, and in North, definitely there is a good amount of investment by large players. I was there a couple of weeks back in Taiwan also, where we see the companies from Taiwan who, yes, there were some of the topics which were still not matured to reach there, but there are a few companies who already have initiated a topic of investment here in a very well ways, right? And we are at a good stage already for that. In terms of chemistry, chemicals, definitely I think, that is where I see an area where the R&D needs to be focused more so that we are reaching to that level where, I look at this as, this is one of the segment where, the consumption is so high. We are talking in millions and millions pieces, right? But it cannot get commoditized. Yeah? And that is where the specialty comes from. And that's where I think, need more focus on the development in terms of the chemicals from the industry. And I think, yes, we have the technologies which is coming in from the experts. And yes, the footprint of R&D was already then in India for semiconductor market. This is what we all know, and this is why we are taking this opportunity. So certainly, I think I see that also as the area where we need to still graduate ourselves in a further way. Yeah. So maybe I answered your question in terms of...
Yes, definitely.
Thanks.
Ambuj, coming to you, how do you see advancement in semiconductor sector and hence support that is giving to the chemistry?
Thank you, Sehul. So first of all, pleasure to be in this panel. So you see, semiconductor industry today is around $600 billion industry, and it is poised to be around $1 trillion industry. Mainly, it is driven by your AI. And 50% almost the growth is by AI, followed by your EV and other sectors. And this AI will start picking up in 2030 to 33 before quantum computing will start to take up the lead, and it will make this industry probably by $5 trillion industry by 2045. And also in the AI, you are going for very high complex chips. So the chips are getting miniaturized. So earlier the chips was around 350 nanometer. Now we are talking of 2 nanometer and beyond. And when you go for high-end chips, you need various tighter specifications. A lot of new steps are being added. A lot of advanced architectures are there. And then, a lot of per capita chip consumption is also increasing because the number of steps is increasing. So if you see the entire chip value chain, so it all starts with your silica, then it goes to make your ingots, then it is sliced to form wafers, and then it goes to a fab. And in the fab, you have various value chain. It starts with photolithography, then deposition, cleaning, planarization, etching, and then you have doping. And then this process repeats several times. And in all the different steps, you have various specialty chemicals, gases going into it. So just if I just as a tentative, if I tell, there are more than 100 number of chemicals and gases that are going into this chip value chain, this fabs. And if total number of chemical and gases, I tell you, it is more than 500. And when you are talking about very small chips, miniaturized chips, the per capita consumption is going to be very, very high. So this gives a very big opportunity for the chemical fraternity, mainly the specialty chemical fraternity, to get into this space. But as you were telling, so there are a lot of challenges, but opportunities also, because as Rajiv was mentioning about purity, so in EVs you are talking about ppm level. In the case of semiconductor, it's not even ppb. In the next generation chip, where it is 2 nanometer and beyond, we are talking about PPT levels. I heard some of the Chinese specifications which are going into 1 nanometer, which Rapidus is developing in Japan. They are talking about PPQ level of impurities. So when the chip was 28 nanometer, and now it has come down to 2 nanometer and below. So the metals has reduced by almost 1,000 times. Your water containing any compounds or any oxygen containing compounds has reduced more than 10 times. So it's not just purity, it's more impurity. And different customers, different fabs have different specifications based on the size of the chip, based on the type of the chip. Are you going to talk about logic chips or are you going to talk about the memory chips? It also depends on the chip that we are manufacturing per month. What is the quantity of chip you are manufacturing per month? So the, if I say the specifications vary from different company by company, also on the packaging. So it's quality is important. You have consistency. You need to have traceability. You need to have repeatability. And for that, you need a high level of advanced capabilities, chemistry capabilities. And that can come from advanced analytical techniques, controlled environment. Then you need, like various high grade of process statistical control, quality control. And the most important thing is here is the people mindset, because there needs to be a full, this type of culture that needs to be in the genes. And generally, I visit a lot of Taiwan, Korea customers and see how they do this, this kind of, how they engulf this kind of culture inside themselves, So it's very easy. They are able to get those kind of levels. They are able to polish the cylinders, clean the cylinders. And it's very easy to talk to them. And when we think about how to imbibe it in our culture, it really becomes tough. So it's not just to buy any technology from any customer, or any supplier and incorporate it. You need to change the mindset of the people, and that will come with time. So that's why this brings a big opportunity to India, because now Tata has already come up and there are other talks also going on. And a lot of other global companies are seeing very good interest in India. And also for foreign sourcing also, as the semiconductor industry is growing, this global customers are seeing for India to supply to the global partners. So the opportunity is humongous. There need to be government support, because I see what government is much more cared about your front-end value chain, which means your chip fabrication or equipments, but they need to think about even your chemicals, because you cannot create an ecosystem in India just based on your fabs or equipments. You need to create an ecosystem for chemicals also. There is a spec policy defined 2 years back, where there was 25% subsidies. Even chemicals was mentioned, but nothing was allotted to the chemicals. There need to be, if there are any policy makers, just I want to tell them, let us talk to the government and inform to the government that you need to specify some allotment of chemicals also in this spec scheme, so that this entire ecosystem is created in India. And this gives a big, humongous opportunity, because the investments are going to be substantial because of the culture creation. So there will be some time taken to go to travel this journey, but there is a humongous opportunity.
Thanks, Ambuj. I think the point of ecosystem is important. Dr. Mayukh, I come to you with 2 points from the previous discussion. Ambuj spoke about ecosystem. Rajiv spoke about key cost drivers. Government and as a country, we all aspire to have backward integration so that we manufacture more in India. At the same time, from a cost point of view, I have to compete with some of the large countries and players who are operating at maybe 100 times the scale of operation that we are. So for a company in India to operate at cost competitiveness point of view, obviously the key raw material becomes very important to compare that from a global benchmarking perspective. When it comes to energy cost, input cost, reagent cost, water treatment cost, how is your view of Indian cost structure vis-a-vis some of the global references?
I think as far as the energy is concerned, we may not be at the point where we should be competitive. But there is optimism on the front because of our thrust on alternative energies. Rajiv just mentioned about the kind of temperatures needed, both subambient and high temperatures. This is a very energy intensive process. We need to come on par with that. If I have to compare the energy cost with Europe, Probably the positive side of the Ukraine-Russia war is the power, how should I say, problems there. The gas that was being supplied to by Gazprom created a situation where companies like BASF had to shut down their plants because of lack of power. So the costs of powers have increased there. And with our thrust on alternative sources, I think we should be able to do that. On the chemical front, our problem is we look global, but we don't act global. I don't think today we have any chemical industry which is global in the sense of manufacturing or assets in terms of volumes of production. We need to go there. All this has the lack of R&D thrusts. I keep telling whoever listens to me that in India we look at R&D as a cost center, not as a profit center. And you can make it a profit center if the management has the foresight to look at these things. I don't see in the horizon today too many companies in India focusing on these chemicals which will take you leapfrogging into global competition. So we have a long way to go.
Absolutely, sir. I think if I look at the nature of PLI, while it incentivizes the output, not necessarily the R&D. But I think that's an input which this forum can give out to regulator as well as the industry as a whole. Thanks for the input, sir. Raju, my next question is to you. We have seen the trend, not just last decade, but generally for any technology product, while the R&D plays an important role, as the economies of scale develops, the cost significantly falls, and then the large-scale adaptation happens. Currently, we see that from a battery chemical point of view, lithium-ion is most prevailing option that we see as an option which is portrayed by the industry. But parallelly, from an academia point of view, from an R&D point of view, other technologies including sodium-ion and others are being explored. How do you see Indian chemical companies and the battery manufacturing companies are evaluating these options and navigating through these challenges?
Okay. Yeah, so over the last couple of years, there has been talk of sodium ion, solid state, lithium sulfur, zinc bromide, all those kinds of technologies are being talked about. It started 2 years ago when there was a sudden spurt of demand for lithium-ion batteries in mobility applications. Prior to that, whatever lithium was available and lithium-ion cells were being made, they were typically going into electronic applications. So therefore, lithium extraction and processing was limited to supplying to that application, and electronic application in today's lithium-ion cell industry is just about 15% or so. So suddenly 2 years ago, there was a shortage of lithium. Lithium prices went up to about $70, $75 per kilo. And when that happened, there was alternates being looked at, and then sodium ion seemed to be an attractive option because sodium is a lot more available, easily available. And the thought was that such a technology would replace lithium ion. It comes with so 2 things has happened since then. One thing is sodium in the periodic table comes below lithium, so it's a heavier element. It does not have that kind of energy density. So any batteries that are made out of lithium, to pack the same amount of energy, it has to be bigger, and therefore it is heavier. So a heavier battery doesn't work well when there is mobility at stake. So theoretically, sodium-based batteries could find applications in stationary energy storage, where the batteries are positioned on the ground and they don't have to move around. But theoretically, yes, but since those 2 years, the lithium price has come down from $70 to $10. So now, lithium ion is no longer expensive as it used to be compared to sodium ion. Sodium ion technology is still not mature. one could make cells at the lab scale or a pilot scale, but the real proof of the pudding is how one scales up a cell manufacturing capability with that technology. And we have seen that there is a major issue, a technology fails for cell manufacturing at the scale-up level, if the scale-up can't be done. So for sodium-ion batteries, stuff like the anode, the cathode, the electrolytes are still nascent compared to a lithium-ion technology, which has been there since around the last 15, 20 years and is getting more and more mature. So sodium-ion is definitely a possibility in the future, but it still has a long way to go. Since we as manufacturers are in the manufacturing side, especially Indian companies, we talked about lack of R&D, but I look at it in another way. R&D is one thing, but there has to be somebody in manufacturing also. If there is nobody to manufacture, then where will product come from? So Indian companies like ours have focused on manufacturing, and we have come out with electrolyte salts, additives, binders, cathode active material constitutes to about 50% of bill of materials of a lithium-ion cell. So when you have that kind of portfolio, eventually all the technology developers get in touch with you. That you make lithium LFP or lithium iron phosphate cathode active material. Could you make something for sodium ion of a similar type? I am developing this technology. Could you develop an electrolyte for sodium ion because you are in lithium ion? The same way with the binder, same thing with the anode. So we therefore are in touch on how the technology is growing on the sodium ion front. Same thing with solid state. The current lithium ion cells use liquid electrolyte, solid state would use solid electrolytes. These are again compounds which require different manufacturing processes, but mostly there are fluorine-based backbone, which typically liquid electrolytes are also fluorine-based. So what I'm trying to say is that as the academia or innovators work on these technologies, when they are on the verge of scaling up, they start reaching out to existing manufacturers like us, and then we work jointly. So having said that, my view or our view is that these alternative technologies are still further down the road. For the next medium or even long-term future, lithium-ion batteries will prevail. There's a lot of more possibility of upgrading existing lithium-ion technology. It has not reached a level that there is no more innovation possible just because the chemistry doesn't allow it. The chemistry allows a lot more energy density possible from LFP chemistry, the electrolyte design, the anode design, the cathode design. So lithium-ion will keep on competing, and the sodiums and the solid state will try to catch up, but it's still a long way to go.
So just Raju, out of curiosity, a question, an extension of this between EV and the energy transition, which is battery part. Can there be coexistence of two technologies, one on EV for lithium ion and sodium ion for the battery storage?
There are some examples I'm hearing where there are small projects of energy storage where we have heard that sodium batteries have been installed. So these are small projects, maybe demonstration projects. Maybe a year and a half ago, I had read some articles that there were some small electric cars in China trying out sodium batteries. Sodium, as I said, because these are heavier batteries, cheaper, likely to be cheaper. They may start off with cheap or low-end models for sodium, and then eventually as the technology matures, then they may move up. So coexistence is possible. Maybe I'll add on LFP technology, lithium iron phosphate, which is the way the world is moving from NMC technology to LFP. LFP is getting further modified into LMFP, where M is the manganese. Manganese allows for higher energy density in the LFP backbone, but has a challenge of the manganese getting, the dissolution happening faster, so there is cycle life issues. But still LMFP is cheaper than NMC. So there are certain cell designs coming up which are a combination of NMC and LMFP in the same cell. It's not that something coexisting separately. These are two different technologies coming together in the same cell. So extreme innovation happening, and this is what makes the sector so exciting. I think 10 or 15 years from now, this will be a very, very different landscape than what we see today as far as the technologies we see on the ground.
Absolutely, Rajiv. Kalpesh, coming to you on the global pricing. I think not just India, but most of the countries are moving towards emerging sectors. And again, the focus for them would be backward integration. Everybody is trying to maybe acquire or do a long-term partnership with mineral countries or mineral companies. Parallel to that, global conflicts, challenges, there is a long list, we are all aware. How do you see amid all of this, the fluctuation of prices of lithium, cobalt, nickel, possibly impacting the battery value chain or the chemical company?
Yeah, so Rajiv just mentioned the pricing of lithium, right? So in 2022, when the initial estimates came out for the EV transition, those were like grossly overestimated. So everyone wanted to jump on the bandwagon, and the lithium prices shot up. In fact, the lithium carbonate pricing was about 500% in 2022 than what it was in 2021. So obviously it was a big shock to the industry. The lithium ion cell, the LFP cell prices shot up. But since then, and I would like to add that it was, this industry itself is a very new industry, even if you take it, on a global scale. India, of course, it's nascent, but even on the global scale, it's about 15, 20 years old, right? So the pricing, I would say it was more because of an immature market reacting to some consulting estimations rather than on the ground realities, right? And since then, the pricing has come down, so it went up to $80 a kilo from about $20 a kilo, and now it's at $10, right? And if you look at the forecast, now, by the way, you ask any of the consultant, nobody wants to give you a forecast after what has happened with that pricing, right? So they give you a 3-month forecast. So, but I would say that being in the industry and where the prices were and where they are now, and looking at the growth, I think the prices are here to stay for at least another 4 or 5 years. They will stabilize as the market stabilizes. So that's on lithium. Lithium is, of course, a very important constituent of both the LFP as well as the NMC. But then the prices for, say, nickel, cobalt also fluctuated. Nickel was twice, and then it came down and kind of stabilized. Cobalt has been high. So in regards to that, there was more R&D development that was going on. The world also then started making a choice. There were about 3 different chemistries on the, 6 different chemistries. And now the world has kind of gravitated towards 2 major chemistries, which are the NMC and the LFP. Even on the NMC side, because of concerns with cobalt mining, right, and both environmental and social concerns, the cobalt usage has come down. So now on the NMC side, they're looking at high nickel chemistries. And LFP, which initially was considered the perfect choice for ESS, but not really a great choice for EVs, has been developed to a point that now if you look at China, most of, or 90% of the EVs are utilizing LFP cells, right? So not only has the energy density gap has been bridged, but with more and more advances on the material side and the battery manufacturing, the cell design side has taken this or has improved the gap between the performance. So coming back to the original question regarding pricing, so these are the ways that the industry has tried to mitigate the price fluctuations. But I would say that for the next 5 years or so, foreseeable future, these 2 chemistries are here to stay. The prices are going to be stable. They look to be stable. Now, the sourcing of these 2 metals, mostly lithium or nickel or cobalt, is again a concern because even though the mines are kind of spread out across the world, but the refining is concentrated in one part of the world, right? So supply chains are trying to de-risk that as well. And like I mentioned earlier, the governments are getting involved because at this point, the governments are trying to see whether they can have partnerships in mining, and the private sector comes in as an off-taker to those. So these are the developments.
Thanks, Kalpesh. Hemant, coming back to you, I think in interest of time, I've got note that maybe max 10 minutes we have. Quickly, 3 challenges that you see for semiconductor industry to operate at a scale and the pace at which we all are envisaging our views till 2030. How do you see navigation by industry on the semiconductor and the material or chemistry part of semiconductor industry for the next 5 years?
So the challenges definitely, I mean, this is the requirement of the market. At the same time, the challenges are equally good to have, right? So first is definitely the investments are high in this kind of industry with the equipments, and that are also certain patented equipments are only, working today in this industry. This is one of the challenge what definitely may not be very short term we can try to overcome, but certainly this is one of the big hurdle for getting into more fast production pace in India, right? Another looks like the skill force, which certainly I think government is putting up lot of efforts in this area. The skill force for this industry, again, as I said, visited the global companies for this. It's a skill. A simple topic is a clean room. To operate in such kind of area, in this industry, fine, pharma is still working on that, but in this industry to get in with this kind of culture is still needs to be developed. And this is one of the area where, again, the skill for the workforce, for the knowledge and the technology is one of the area. Another is, this semiconductor topic started very well with the fire in India during COVID time because of the supply chain topic. So I see supply chain is a key of this industry. And in this also, I mean, certain areas like assembly, testing, and packaging. Yeah? So for an example, I mean, this is a large industry with such a huge consumption. Sustainability also will become one of the most important topic here, right? So looking at that in future may have a larger challenge. So it is better that the knowledge is there, and today we try to go parallelly on that line also. So for an example, packaging is one of the topic where, what kind of packaging is being used with, whether it is a sustainable solution, yeah, whether this is environment friendly solution, that may not create the issues in a short term even, not even long term. Long term will be a high challenge, right? So such kind of challenge, I see those needs to be attended at this stage. And certainly R&D, as I emphasized on that earlier also, which needs to be taken care of, right?
Thanks, Hemant. In fact, I was speaking to one of the chemical companies, and they said for semiconductor, typically the industry, without looking at emerging sectors, looks at default ratio or defect ratio as parts per million. Moment we go into some of the niche sectors like this, it could be parts per billion. We move from ppm to ppb, and globally it could be also ppt. We don't know. So I think only time will tell. Thanks, Hemant, for the view. Ambuj, coming to you. You also look at data centers and artificial intelligence related opportunity on the liquid cooling side. How do you see these opportunities evolving in India, one? And what is the opportunity available for chemical companies into these applications?
Thank you, Sehul, for asking this question. So data is the new oil, so everyone knows, and this data center is an environment where data is stored. So data center, if you see the industry, currently it is around 80 gigawatt industry, and it is poised to be around 220 gigawatt by end of this decade. And this again, it is driven by the AI as the chips industry. So AI workload is currently just 40-45 gigawatt, which will be more than 150 gigawatt by by end of 2030. And there also again Gen AI, which has just started in 2023. And there the CAGR growth is around, appears to be around 94% by end of this decade. So now when we are talking about AI, Gen AI, so there, the CPUs and GPUs are the main heat emitting sources, main energy consumers. And then what is happening that the energy consumption is very high, the heat dissipation of these chips are very high. If you just see the data center in US, so the US data center consumes around 4% of electricity in the entire US. Just today I was reading an article, so the data center across the world, they consume electricity more than what France consumes. In 2030, data center will consume more electricity what total EV industry will consume. So that the managing heat is going to be very big challenge in the future. So currently the data center, they use traditional cooling methods like air and water cooling, but the data centers are coming up with a new solution. The solutions are, one, the change in the infrastructure, change in the rack densities, and another is the change in the cooling methodologies. And even in the cooling methodologies, the liquid cooling is the key enabler. So in the liquid cooling, you have direct-to-chip cooling as well as you have immersion cooling. So direct-to-chip cooling can be single phase or two phase, and immersion cooling can also be single phase and two phase. So, but till 2025-26, you have rack densities around 25 kilowatt, where you can go with the DTC, even dual phase can go up to 50 kilowatt. When we are talking about data centers, more than 50 kilowatt, 100 kilowatt and above from 2026 onwards with the next gen chip requirements, then the immersion cooling comes into play. And again, as you go further, the two-phase immersion cooling comes into play. So what happens in two-phase immersion cooling is, there is a dielectric fluid. So the entire chips are immersed in a tank where this fluid is kept. So this fluid has very advanced properties. It has heat dissipation of more than 20 times than normal fluids. And also it has very poor conductivity and very high dielectric strength. So when the chips or the servers are kept inside the tank, so with the heat of the chips, this fluid will evaporate and travel to the top of the tank. And there is a condenser with in the condenser, with the heat exchange, the fluid will again travel to the bottom of the tank, and this way the cycle will be established. So if you see the market of this liquid cooling, so currently it is around $500 million. So it is expected to be around it is $500 million industry. By 2030, it is expected to be around $1.5 billion industry. And by 2035, it is expected to be around $3 billion industry. So we are talking about a $3 billion industry size. And this immersion cooling fluid is going to be the key enabler in the future to take or to manage the data center needs. Also, if you see, some of the customers have already developed. Even Navin is partnered with some of the global customers for two-phase immersion cooling. So here, this customer has already tested with global hyperscale data centers, and based on the results, this two-phase immersion cooling, the fluorinated one, so they are able to save the total cooling energy by more than 90%, total footprint by more than 60%, total cost of energy by more than 40%, almost zero maintenance, and almost eliminates total water usage. So this is actually also on the goals of the carbon neutrality, decarbonization. And even if you see for India, with India AI mission, just I was reading an article in Mumbai, it is going to be the 6th largest data center construction is going to happen. So India is going to be a key place where these all data center companies are looking to start looking to focus. And like Reliance, Adani, WebWork, entity, all have very large interest in India, but the decision of the fluid is being taken by the their locations worldwide. But this is going to be very crucial. They need to understand, because if you don't enable this kind of liquid cooling technologies in data centers in India, then how you will manage this kind of electricity? The electricity consumption is going to be humongous. So this is the need of the time, and obviously I hope this will shortly come to India. Already global customers have started to adopt this technology, and this is the real sustainability solution which the world has to adapt.
Thank you, Ambuj. I think in interest of time, that's the last feedback and the question that we had. On a lighter note, if I have to summarize, if I ask Gen AI to summarize the conversation of last 1 hour and the most spoken quantum in the discussion, I think the response would be 2030. That will come out as a key number. And the reason we are referring to 2030 is because, as we said, it's an emerging one. So while the investment intent is very strong, on-ground implementation, commissioning of many of these plants will happen by 2028, 2030. But to obviously participate and take first movers advantage, the R&D discussion and the kind of a strategy decision has to happen now. So I think that's the reason why the topic is very much relevant today. Thank you, gentlemen, for participation and your expert view. Thank you.